dear children, welcome back to chemistry class. In our previous class, we have learned what is matter. We have also learned how we can distinguish one matter from another. That is with the help of physical properties and chemical properties. We have also understood which are the three main states of matter, or otherwise the three different states in which a matter can exist. They are, as you see here, solid state, liquid state and gaseous state. So these are the three important states in which a matter can exist. So in today's class, we are going to learn about few important properties of each of these states of matter. But before we go into that, we need to know few more important things. We have already learned in our last chapter that an atom is the basic unit of an element, isn't it? Yes. So every substance that we see around, which is a form of matter, is also made up of these tiny particles called atoms. Or in other words, the basic unit of a matter is also an atom. Now let us see how are these tiny particles or atoms arranged in case of a solid state, or when it is in a liquid state, or when it is in the gaseous state. As you see here in this picture, in case of a solid state, the tiny particles called atoms are arranged like this, which means they are very close to each other. While in case of a liquid state, these tiny particles are slightly far apart, like how you see here in this picture. But in case of the gaseous state, these tiny particles are very far from each other. Or otherwise, we say that they are far apart from each other. So in case of solids, the arrangement of atoms are close to each other, while in case of liquids, these atoms are arranged only slightly far apart from each other, while in case of gases, they are far apart from each other. With this understanding, we will now see which are the important properties and how do solids, liquids and gases differ with respect to each of these properties. The first important characteristic or property is shape. We will now see how do this property differ in case of solids, liquids and gases. We all know that every substance that is there around us, which is in the form of a solid, has a definite shape, isn't it? Yes. Now look into this picture here. This is a cuboid. We know that it has a fixed shape. Likewise, every substance that is there around us, which is in the solid form, has a fixed shape. So in general, we say that solids have a definite shape. What about liquids? Now take a liquid in a beaker and as you see here in this picture, pour it into different containers like this. Now what do you observe? We see that as the liquid is poured into each of this container, we see that the liquid takes the shape of the container in which it is present, isn't it? Yes. So we say that liquids do not have a definite shape, but they take the shape of the container in which it is poured in. Now, what about gases? Do they have a definite shape? Let us see that. Now, as we see here, gas or air is filled inside balloons that are in different shape. Or otherwise, take a balloon that is filled with air and now you try to squeeze it with your hand. What do you observe? We see that the shape of the balloon changes, isn't it? Yes. Now this balloon that was in the oval shape has now become an elongated shape. This means that the gas that is there inside the balloon has no definite shape. That is why the shape of the balloon has changed, isn't it? Yes. Or otherwise, try to transfer this gas that is there inside this balloon into a container that is closed. Now, what do you observe? As the gas is transferred into the container, we can see that if it is a colored gas, we observe the gas fills the container completely, isn't it? This is because gases do not have a definite shape. So from this we conclude that solids have a definite shape, liquids do not have a definite shape, but they take the shape of the container in which it is poured in, and gases, they do not have a definite shape. Now let us look into the next important characteristic, that is volume. The amount of space occupied by a substance is called volume. Every solid object, it needs a fixed amount of space, isn't it? Yes. Now look into this picture here. We see that initially the level of water that was filled in this container is up to this level, as you see here, that is pointed with this cursor. Now, as a solid object was inserted inside this beaker, which was half filled with water, we observe that the level of water rises from this level to this level, as you see here in this picture. Now, why do you think it is so? This is because as the solid object is inserted inside this beaker that was half filled with water, this solid object occupies a space inside the beaker. That is why it has pushed the water in this beaker up to a new level. So this shows that this solid occupies space. So therefore, we conclude that solids have a definite volume. Now, what about liquids? Look into this picture here. We take, say, a measured amount of liquid inside a container, as you see here. Say 200 ml of liquid in this bottle. Now, as we transfer this liquid carefully into another bigger container, what do we observe? As it gets transferred, we see that it is the same 200 ml that is there in this new container also. So we observe that only the shape of this liquid has changed, but the volume remains the same. So this shows that liquids also have a definite volume, which means they occupy a definite amount of space. Now, what about gases? Look into this picture here. Initially, gas is filled inside a gas jar. That is a colored gas, as you see here, that is filled inside a gas jar. Now, it is closed with a lid. Now, insert another gas jar on top of this. Now, slowly remove the lid from this gas jar. Now, what do you observe? We see that this gas that was initially there in this gas jar has now filled the entire containers completely. Or otherwise, if we transfer this same amount of gas into another container which is bigger, what do we observe? We see that the same gas that was there in this containers, it has now filled this bigger container completely. So this shows that the amount of space that is occupied by gases are not fixed. So we say that gases do not have a definite volume.